Okay, welcome to screencast number 3 for Unit 6, Lesson 1. I'm on page 274 and 275. Okay, well, first of all, on page 274, basically, it's just answering some questions. You live on Earth. What is Earth's place in the universe? Earth is part of the solar system. What objects make up the solar system? Solar system is located within a partial spiral arm of the Milky Way galaxy. And what's a galaxy? So those are all questions that you should be able to answer, considering the fact that you have been listening to the screencasts previously. All right, so on page 275, how are distances in the universe measured? Distances between most objects in the universe are so large that astronomers do not use kilometers to measure distance. Instead, astronomers measure distance using the speed of light. The unit of measure is known as the light year. A light year is the distance that light travels through space in 1 year. Okay, I know that it says light year, but it's not a time, it is a distance. Why is it called a light year? Because it's defined as the distance that light travels in 1 year. Okay, light travels through space at about 300,000 kilometers per second. And if you do the conversion, that's 9.5 trillion kilometers in 1 year. The closest star to the Sun and Earth is Proxima Centauri. Okay? It takes light about 4.3 years to travel from Proxima Centauri to us. Therefore, the distance from Proxima Centauri to Earth is around 4.3 light years. Okay? Light from the Sun travels to Earth in a little more than 8 minutes. Thus, the distance from the Sun to the Earth is around 8 light minutes. Now, a lot of times we just talk about the distance from the Earth to the Sun in kilometers or miles. But still, I know that the solar system seems like a huge place, but in the grand scheme of things, it's a really teeny tiny portion of the universe. And so when we start talking about really big distances, kilometers is no longer useful because you're talking about trillions of kilometers, and it's just not helpful to think of those numbers because they're so big. So instead, we talk about distances in light years. Now, I could take the 4.3 light years, which is the distance from us to Proxima Centauri, and I could convert it to kilometers, but I would come up with something just, crazy big. So it's just easier to think of it as 4.3 light years. Okay. How do distances affect space travel? Our fastest interplanetary spacecraft, Voyager 1, travels through space at about 17 kilometers per second. At this speed, it would take Voyager 1 more than 70,000 years to reach Proxima Centauri. Okay. I'm going to do 12 with you guys, and I'm going to kind of show you how these things are converted into a distance that something would travel in a year. So here we go. Number 12 says, if Voyager 1 is now traveling or now moving at 17 kilometers per second, how far will Voyager 1 travel in 1 year? Well, I have to start out with 17 kilometers per 1 second. Okay, so I start with 17 kilometers per second. But if I want to know how far that's going to be in a year, then I have to convert, and I have to think about how many seconds are there going to be in a year. So I have to take 17 kilometers per second and multiply it. There are 60 seconds in 1 minute. Okay, so I multiply it by 60. There are 60 minutes in 1 hour, so I multiply it by 60 again. There are 24 hours in 1 day, so I've got to multiply it by 24. And there are 365 days in a year, so I have to multiply it by 365. Okay, so I take 17 times 60 times 60 again times 24 times 365. Okay, and that is 536,112,000 kilometers that Voyager 1 will travel in 1 year. Okay. 5, 3, 6, 1, 1, 2, 0, 0, 0, and my units are kilometers per year. How do I know? Because I can look up here. I don't know if you guys have done this much in math or in algebra, but the rule is if I have to convert and I'm switching units, then things that are catty corner cancel. So seconds is down here, seconds is catty corner up here, so they cancel. Minutes are down here, minutes are up here, they're catty corner, so they cancel. Hours are down here, hours are up here, they're catty corner, so they cancel. Day down here, day up here, catty corner, so they cancel. The only thing that I'm left with on top is kilometers. The only thing that I'm left with on bottom is years. So my number, when I wind up doing all the multiplication, I get kilometers per year. Okay? Basically, you would multiply all the top numbers together, which is 536,112,000, and you would divide by the numbers on bottom, but the numbers on bottom are all 1, so we don't really have to do that. But anyway, that's how far Voyager 1 will travel in 1 year. Okay, I'm now on page 276. How are sizes in the universe measured? Okay, the sizes of objects in the universe vary greatly. The units used to measure the size of an object in the universe depend on the object. The size of smaller objects, such as moons, planets, and stars, are often measured in kilometers. Typically, when you measure those objects, you're usually measuring the diameter. The size of these objects is often given as the diameter because they are close to being spherical. The diameter of Earth is about 12,742 kilometers. The diagram of the Sun is 1,391,000 kilometers, making it about 109 times the diameter of the Earth. Light years are used to measure the size of large objects in the universe, such as nebulas, galaxies, and galaxy clusters. The Milky Way galaxy has a diameter of about 100,000 light years across, meaning that if you could travel at the speed of light, remember the speed of light is 300,000 kilometers per second, it would still take you 100,000 years to get all the way across the Milky Way galaxy. Okay, and I know that's kind of mind-boggling how big it is, but that's the way it is. Okay, most of the other galaxies in the local group are smaller than the Milky Way. Okay, so the Milky Way galaxy is one galaxy in sort of a little cluster of galaxies, and that little cluster of galaxies is called the local group. Why do we call it the local group? Because it's our home group. Okay, the Milky Way galaxy is in that group. Okay, the local group is about 10 million light years across. Okay, and our little local group of galaxies is also part of an even bigger supercluster of galaxies known as the Virgo supercluster. The Virgo supercluster is about 10 times wider than the local group, so it takes light 100 million years to travel all the way across. Okay. What is the size of the observable universe? Well, scientists still do not know the actual size of the entire universe. They only know the size of the universe that they can observe. Radiation from objects that formed early in the history of the universe have not yet reached Earth, and that takes time. Scientists have been able to take images of radiation that took around 14 billion years to reach Earth. This data tells scientists that the universe has a radius of at least 14 billion light years. However, the universe has been expanding in all directions since its formation. This means that objects are moving farther apart at an ever-increasing rate. Because the universe continues to accelerate outward, the universe is much larger than 14 billion light years in radius. And using the best current scientific techniques, it's estimated that the universe is around 93 billion light years in diameter and growing larger. Okay, so I know that kind of boggles the mind, but there it is. Okay, the last page in this lesson is page 277. What is the structure of the universe? The universe can be defined as space and all of the matter and energy in it. However, the definition does not tell us about the structure of the universe. Astronomers now know that throughout the universe there are areas where galaxies are densely concentrated. These are areas where galaxies are found in what are called clusters and superclusters. Clusters contain as many as several thousand galaxies. Superclusters can be made up of 10 or more clusters of galaxies. There are also areas throughout the universe where very little matter exists. These are huge spherical volumes called voids. Astronomers have begun to think of the universe as having a structure similar to a three-dimensional web. Clusters and superclusters of galaxies make up the web, and then the large empty volumes within the web are voids. It takes light hundreds of millions of light years to cross the largest voids. Okay, so the structure of the universe is basically three-dimensional spiderwebby. It's clusters of galaxies surrounded by a lot of empty space. Okay, all right, so let's go back and review what the highlights are for these pages. Okay, this one should give you an idea of what I highlighted on page 275. I highlighted the definition for light year. It's the distance that light travels through space in 1 year. And remember that light travels through space at a speed of 300,000 kilometers per second. Okay. Just a reminder, the distance from Proxima Centauri to Earth is around 4.3 light years. Other than the Sun, Proxima Centauri is the closest star to us. Okay, on page 276, under how are sizes in the universe measured, make sure you find the sentence that says the size of smaller objects such as moons, planets, and stars are often measured in kilometers. And then the next paragraph, light years are used to measure the size of large objects in the universe such as nebulae, galaxies, and galaxy clusters. Reminder that the Milky Way galaxy, which is the galaxy that our solar system is in, the Milky Way galaxy is part of the local group, and the local group is part of a large supercluster called the Virgo supercluster. Okay, there's one thing I want you to put on the back of your lesson. I will make sure that you did it. It'll count as part of your lesson points, and it's basically an address for the Earth. Okay, so if somebody, alien out in space, wanted to write us a letter, they would need to know where we were. So let's start. If you think about the address on a letter, the top line is the most specific. It's the actual mailbox and the owner of the mailbox that it's going to. So our most specific, they will have to address it to the Earth. Now, where is the Earth? It is number 3 in the solar system. Where is the solar system? It's part of the Orion arm in the Milky Way galaxy. Which is part of the local group which is part of the Virgo supercluster, which is part of the universe. Okay, the Earth, number 3 solar system, Orion arm, Milky Way, local group, Virgo supercluster, universe.